Good evening, everyone. Can someone confirm if I'm audible?
Yes, sir.
Okay, thank you. Okay, so let's start the week 9 live session of the course Digital Electronic Circuit, which is taught by Professor Gautam Saha from IIT Kharagpur. And I will briefly introduce myself. I am Anand Singhal, pursuing PhD from IIT Jodhpur, and I'll be assisting you in solving the week 9 assignment problem, which will be helping you in uh, the examination of this course. So, this is the course outline. So as we know that in the initial weeks of this course, we have covered the combinational part of the circuit, which is from week 1 to week 6. Uh, Give me a moment. Yeah, which is from week 1 to week 6. And then we started studying the sequential part of the circuit, which is the most important component of this course. And till now, we have covered the basic flip flops and all the registers and basically all the synchronous counters which require a clock at the same time. In this week, what we'll be covering the ripple counters, which are also known as asynchronous counters. And in this, we require application of more application of knowledge since we have clocks which are not synchronized. So we'll be dealing with some up and down counters, some synchronous counters also, and we'll design some counters using some flip flops. So let's start the week's 9 session with the first problem. So here's the problem. It says a ripple counter with positive as triggered flip flop is given in the circuit below. So as you can see, these are T flip flops, and the characteristic equation of T flip flop is nothing but Qn plus 1 is T XOR Qn. So on the basis of it, we'll be solving the problem, and we know that when T is equals to 1, Qn is nothing but Qn bar, it toggles, and when T is equals to 0, Qn plus 1 remains Qn only. So the question says that the initial state or the present state of the flip flop is 0 0 0. So let me write it here. It is given Q naught, Q1, and Q2 is initially 0 0 0. Now it says that the next state will be. So as you can see here, the application of clock is only in the first flip flop, and the other clock depends. All the other clock depends on the output of the flip flop generated by this T naught. So I'm marking it at 0 1 and 2. So the output or the clock for T1 and T2 will depend upon the input or the output of this T naught flip flop. So let's try to do this question now. So as you can see in the input of this T naught flip flop, 1 is given. So whenever this positive edge of the clock will come, it will toggle. So initial state is Q naught is 0. So when we apply the first pulse, since T naught equals to 1, so Q naught will toggle to 1. So now we have a Q naught as 1. So we know that Q naught bar will be nothing but 0. And since it is 0 and it is a positive edge triggered flip flop, the clock will not get 1 here. So this toggling won't work for the next flip flop. Uh, so yeah, so what will happen now since this clock is not getting a positive edge trigger, this T not T1 equals to 1 will not work. So whatever Q1 was in the initial state, it will remain the same. So Q1 was initially 0, so it will remain as 0 only. uh, and then Q1 bar will be 1 as Q1 is 0. So now since it is 1, this clock will work, and at the positive as triggered since T2 equals to 0. So we know when T is equals to 0, what happens? Qn plus 1 remains as Qn. So it will remain, the Q2 will remain same as the previous state, which is 0. So the correct answer to this question will be 1 0 0, which is option number C. Is it clear? Let me check. Okay, you are saying it 1 1 1. Is it clear now? Sujata, is it clear? Yeah, okay. Okay, we shall wait for 2 minutes. We will proceed to the next problem. Yeah, do you have any doubt? Okay. Okay, so since if this problem is clear too, so let's try to solve a similar problem. So I'll give you 2 minutes to solve this problem. Come up with the answer in the chat box. Okay, I expect answer from everyone, so please try to be interactive. Okay, so let's try to solve this problem now. So as you can see in this problem, all the T knots are 1. So for every positive edge trigger clock, it will toggle. So let's try to solve the problem. It is said that the present state is nothing but 0, 1, 0. So I'm writing it here. It is 0, 1, 0. So as you can see, this T naught equals to 1. So since Q naught was 0, so it will toggle to 1 when the positive edge of the clock will come, or yeah, when the positive edge will come. So it will make Q naught bar as 0. I hope it is clear. So when Q naught bar will be 0, so this clock will not come. So whatever it is in the initial state, it will remain the same for Q1. So Q1 will remain 1 only. And then Q1 bar will be 0. So again, whatever Q2 was there, it will remain same in the next state. So the correct answer to this problem is 1, 1, 0, which is again option C. I hope it is clear. Yeah.
Sir, could you please explain what really was asked in question?
Sorry, what? Can you repeat?
Actually, yes, what was really asked in question? This is the real
Okay.
ripple factor. Yes.
Yeah, sure, sure. So it says it is a counter which is working when it is positive edge triggered. So at every positive edge, what will happen? This flip flop will work. You know, na? T when t is equals to 1, the next state of the t flip flop is nothing but qn bar, and when t is equals to 0, the next state is nothing but qn. So the question says that it is a positive edge triggered flip flop, and since it is not a synchronous flip flop, you can see the clock of the next flip flop depends upon the output of the previous flip flop. So it is a asynchronous circuit. So the question says that the initial state was, let me use some different ink. Yeah. Question says the initial state was here 0, 1, 0. So it says after this application of clock, what will be the next state?
Okay. Yes.
Yeah. So do you understand the problem?
Yes, sir, I got it.
So yeah, so now what is happening? This is the initial or the present state. Now as you apply a clock, the first clock will work when it is positive edge triggered. So since t is equals to 1, the output will toggle. So initially it was 0, so it will become 1. Is this part clear?
Oh, initially it was zero, so now it is one. Okay.
Yeah. So yeah, this is 1 now. So since this is 1, so Q naught bar will be 0, right?
Q bar is zero. Yes.
So when it is 0, so it will not work because since it is a positive edge triggered clock. So Q naught bar equals to 0 will not make this flip flop work. So whatever the input of in the previous state it was, it will remain the same. So Q1 will remain whatever it was in the previous state. So I have written it as 1.
Oh, okay.
And then again Q1 bar will be 0. So again this will not work since there is no positive edge triggering here. So now whatever the previous state was there, it will remain the same. So it was 0 initially.
So,
So I have taken
so,
it as 0.
so actually Q naught after second term it was zero. So when we will do the Q1 bar, so zero. Q1 bar
Yeah.
will be get again 1, na? So after 0 to should
Which?
be
Oh, yeah,
so
yeah.
third term where we have
This,
written.
this, right?
Yes, sir, yes, sir. Where it
So,
is
yeah.
0.
So here you can see the clock is zero, right?
But it should be 1.
No, Q1 is one, so Q1 bar will be zero, right?
Okay, okay. So means from the upper side we are doing a bar. Matlab, I was thinking we are doing bar. Huh, okay, sir, I got it now.
No, no. You see, this is a basic flip flop. You have a certain input, you have a clock, and you have two outputs which are Q and Q bar. So this is Q1, this is Q bar. Is
Oh,
it clear now? Yeah.
yes, now
Is it clear now?
yes, sir, yeah, condemn.
Yeah. Yeah. No problem. So let's wait for 2 minutes. Then we'll proceed to the next problem. Do you have any doubt? Okay, so let's proceed to the next problem now. Okay, so the question says that the number of unused state means when there will be, since this is a three flip flop circuit, so there will be total eight states, right? 2 to the power n is the formula. So the question says that from these eight state, how many will be unused? So is the objective of question clear?
Yes, sir.
Okay. So let's proceed. So this is again a asynchronous circuit since the clock. No, it is a synchronous circuit since all the clocks are getting at the same time. So we'll just write the equations of the
सर
concerned flip.
सिंक्रोनस एंड एसिंक्रोनस डिफरेंस थोड़ा बता दीजिए.
Okay, sure. So okay, I'll write it here. Asynchronous and synchronous. The main difference is in the synchronous circuits in all the flip flops, the clock will work at the same time. So as you can see, I'm having a single clock which is working here. You can see also this is a clock, right? And the same clock is applied at the same time to all the flip flops. And in the asynchronous circuit, as we have done in the previous question, the previous clocks were dependent upon the output of the previous flip flop. Is it clear? Jagannath, is it clear?
सर.
Okay, okay. So let's try to do this problem. Fine. So since it is a synchronous circuit, so we'll just write the expression. So you can see, let's mark it as 0, this is 1, and this is 2. So for the first or the 0th flip flop, J0 and K0 both are 1. This means toggle. So plus 1 will be Qn bar. Is it fine?
Yes, sir.
Again, for the next flip flop, J1 and K1, are they both equal? No. So J1 is given by this, as you can see. It is an AND combination of Q0 and Q2 bar. Q2 bar and Q0. Whereas K1 is nothing but Q0 only. And now if I write for J2, J2 is nothing but an AND combination of this q naught and q1, and k2 will be, what is this k2? K2 is q naught. Everyone agrees with this? If you have any doubt, I can repeat.
Yes.
Okay. Okay, so you are saying, sir, please assignment 10. So, see, this week is for assignment 9 problems. So, this is a week 9 lecture. So, in the next week, we will be dealing with assignment 10 problems. This week will cover the assignment 9 similar problems. So, if it is clear, so we'll proceed now. So, it says the number of unused states. So, we'll start with, as usual, with the not Q1 and Q2 as 0, 0, 0. So as you know that in the first flip-flop, it will always toggle since both J naught and K naught will be 1. So in the next state, Q naught will be 1. Is it fine with everyone?
Yes, sir.
So once Q naught is 1, so as you can see in this, if I put Q naught as 1, so it will make this 1, and initially Q2, so for this Q naught was 1 and Q2 bar was 1. So it will make this as 1 and this as 1. So again it will toggle J1 equals to K1 equals to 1. So it will make Q1 as 1. Is this step clear?
Yes, sir.
And then for the J2 part, again Q naught was 1 and Q1 was, in the previous state we have just written it as 1, and then Q naught was 1. So it will again make it toggle. So Q naught was 1, and then what was the J2 expression? It was Q naught Q1 bar. So Q1, Q1 bar, give me a moment. So J2 expression was Q naught and Q1 only.
Sir, Q not 0.
Sorry.
Sir, before applying clock, Q not equals to 0, sir.
Okay, yeah. So initially Q naught equals to 0. So,
Then J1 equals to 0, sir.
okay, yeah, yeah. Yes, correct. I've written it here wrong. So Q naught will be 0, and then J and K both will be 0, right? Since K1 is nothing but Q naught. So Q1 will remain as it was in the previous state. Is it fine?
Yes, sir.
And then for J2, Q naught was 0, so it will again be 0, and for K it was 0. So again it will remain in the same state. Is it fine?
Yes, sir.
Okay, so now we'll proceed for the next clock cycle. So again it will toggle Q naught, we can write it directly. It will be something like this for every state. So in the sense in the previous state Q naught was 1 and Q2 bar will be nothing but 1. So this will make J1 as 1 and Q naught will be 1. So it will toggle, right?
Yes, sir.
And then for J2 it will be Q naught into Q1. So Q1 was 0. So J1 will be 0, and sorry, J2 will be 0, and then K2 will be Q naught, which is 1. So it will make it 0. Is it fine?
Yes, sir.
Okay, I'll do it similarly for the next step. So since Q2 equals to 0, so in this step what will be, J1 will be 0, K1 will be 0, Q1 will remain the same, and then in this step J2 will be, since Q naught is 0, so it will also remain same. Now Q2 bar. So in this step J1 equals to K1 equals to 1, it will make it 0, and then Q naught is 1, Q1 Q naught it was 1, yeah, it will again toggle. and then in this state also q naught is 0, so it will remain the same, and then this part is 0 and 0, yeah, it will also remain the same. Okay, let me proceed to the next problem. So it will be 0 now, since q naught is 1 and q2 bar is 0. So for this state j2 will be 0. Yeah, q2 bar is 0 because, and q naught will be 1, so it will be 0, and j2 is q naught into q1, which is 0, sorry, and then k2 will be q naught, which is 1, so it will be 0. So we have reached back to the initial state. So there are 1, 2, 3, 4, 5, and 6 u states. Is it fine? Any doubts in this?
No, sir.
Okay. So now the question has asked that the number of unused states. So total states were 8, and we are only having 6 states in the counter. So the correct answer to this problem will be 2. And those two states will be, there is 0, 0, 0, there is 0, 1, 1, there is 0, 1, 0. So those two states will be nothing but, there is no 0, 1, 1 and 1, 1, 1. So the correct answer is 2, and those two states are 0, 1, 1 and 1, 1, 1. You can take a look. We'll proceed to the next problem in 2 minutes. Okay, so you can try this problem. You can try to solve this problem. We'll start in 2 minutes. Any answers? So first of all, can you tell if it is a synchronous or a asynchronous circuit?
Synchronous circuit.
Synchronous, sir.
Yeah. So do you reach to any conclusion? It says the value of n is okay.
6.
Okay, so I get the answer which is 6. Let's see if it is correct or not. So yeah. So since it is a synchronous circuit, so we'll try to write the expression for corresponding flip-flops. And we know in D flip-flop, Qn plus 1 is nothing but Qn. So let me try to write D1 first. D1 is this is the OR gate, and let me try to write this is nothing but Q3 bar, and this is nothing but Q1, and now this will be Q1 Q3 bar, and this part will be, this is again a AND combination of Q3 bar and Q2. So Q3 Q2 bar. It will be nothing but Q3 bar which will come, and is it fine with everyone? D1?
Yes, sir.
Okay, so we'll write for D2 now. So D2 is again a OR combination of Q1 Q3 bar, and this is a AND combination of Q3 bar, and this is Q2 bar. Okay, so it will be Q2 bar and Q1. Is it fine? Everyone, is it fine?
Yes, sir.
Yes, sir.
Okay, so now we'll write for D3. So D3 is nothing but a AND combination only of this thing is Q1, and this thing is Q2. So D3 is nothing but Q1 Q2. So on the basis of it, we'll be writing the equation. So yeah, let's start. So we have D1, D2, D3, or Q1, Q2, Q3. Since in the case of D flip flop, it will work. So let's write. Let's start with 0, 0, 0 first. So D1 will be Q3 bar. Let me write it here. Q3 bar will be 1 into 0. So D1 will be 0. So it will make Q1 as 0, and then D2 will be Q3 bar 1 into 1, and then D3 is Q1 Q2, which is 0. Is it fine, this step?
Yes, sir.
Okay. So now we'll similarly proceed for the other step. So Q3, this will be 1, and since Q1 is 0 and Q2, so it will be 0, and D3 is Q1 Q2. I'm just using these expressions to write the next state. Is it fine?
Yes, sir.
Yes, sir.
Oh, okay. So similarly, we'll write for all the states. So I'm writing correspondingly. You can also write in your notebooks. So this will be 1, this will again be 1, and Q1 Q2 it will again be 0. So now again 0, it will be 1, it will be 1, Q1 Q2 will make it 1, and now Q3 bar, so it will be 0, it will also be 0, and it will be 1. Then in the next year it will be 0, it will be 0, and Q1 Q2 0. So we have reached back to the initial state from 0 0 0 to 0 0 0. So let's see how many states does it have. 1 2 3 4 5 6. So yeah, n is nothing but 6, so it is a mod 6 counter. Is it fine?
Yes, sir.
Yes, sir.
Okay, so the correct answer to this problem is 6 only.
So we are not taking the last one. Before one we are taking with zero, and last one we are not taking zero, right?
Yeah, so since we have counted this state initially only, so 0 0 0 has already come, so we will not count it again.
Okay, okay.
Yeah. So we'll start the next problem in 2 minutes.
Sorry, is that formula is there? D1 is equal to Q bar plus Q1 plus Q2 like that.
This
This is
formula you are talking about?
sir, yes, yes.
So this formula I made using this circuit. So it was a complicated circuit, so I just simplified it. So you can see D1 is nothing but a OR combination of these two wires. Now this wire is nothing but a AND combination of Q1 and Q3 bar,
Uh,
and this wire is a AND combination of Q2 and Q3 bar.
okay.
So D1 here will be Q2 Q3 bar plus Q1 Q3 bar. So I've taken Q3 bar common, so it will be Q3 bar Q1 plus Q2. So I've written it here.
Okay.
Yeah,
So
similarly for D2 and D3, I have written the expressions and then solved the circuit.
okay, fine.
Yeah, sure. We'll start the next problem in 2 minutes. Okay, so shall I proceed? Fine. So you can try to solve this problem. Uh, Maybe I can give you 2 minutes to solve this problem. Then I'll try to solve by myself. Anyone with the answer? Okay, so I'll try. So the question says we have a 3-bit synchronous counter, and it says that let the propagation delay of the NAND gate. So propagation delay of NAND gate is given as 2 nanoseconds, and that of a counter. So for the counter, that there is no propagation delay. It says it is 0. So it is a ideal counter, and the frequency is given as 1 gigahertz. So from the frequency, we can calculate the time period, which is nothing but 1 upon frequency. So it will be 1 upon 1 gigahertz, which is nothing but 1 nanoseconds. Is it fine till here?
Yes, sir.
Okay. So now we'll do what we do. So in this 3-bit synchronous counter, we'll again start with the initial state as 0, 0, 0. So this will be 0. Okay, so it says Q2 is MSB, so I'll write it in the backward way. Q2, Q1, Q0. So once it will be 0, so 0, 0, 0. So I'm, since it is a NAND, sorry, this is a NOT gate, so here it will be 1, here it will be 0, and here it will be 1. And 101, so it will be 0, so it will be 1. So now, so it will go to the next clock, since it is a positive edge triggered clock. So in the next clock, it will be 001. Now, if I write here as 001, so again it will be 100, and again it will be 1. So it will go to the next pulse now, which will be 0 1 0. Right? Is it clear to everyone? This step is quite important. Is it clear, everyone?
So please repeat it once, sir.
Sure. So I have started with an initial state of 0 0 0. So we have an additional requirement of the clock. When this will be 1, then only the flip flop will go to the next state, or it will go to the next up state. So this is basically a up counter. So we'll start with 0 0 0, and we'll go, sorry, this will be 0 0 1, 0 1 0, 0 1 1, and so on. And it will end at 1 1 1. So there is a dependence on the clock that this NAND gate is posing some conditions. So I'm checking for every state if this is getting 1 or not. So for 0 0 0, since here it is a not buffer, not bubble, so it will be 1 0 1, since it is a not. So 1 0 1 will give the output as 1. So whenever this reset bar will be 1, it will go to the next clock. There will be a positive asterisk ring. Fine. Is it fine till here? Is it fine?
Yes, sir.
Okay. So for this part you can see. So now this is the first step. Now it will become 1. From 0 0 0 it will become 0 0 1. So now I'll check similarly for 0 0 1. And when I check for 0 0 1, it was coming as 1 0 0, and again it was coming as 1. So now the next part will be 0 1 0. So this is 0, this is 1, this is 2. So now I'll check for 0 1 0. Maybe I can use some different thing. So when it is 0, it is 1, and this is 0. So what will happen? This will be 1 1 1, and that will make it as 0. So there will be no further counting. Once it will get 0, it will go back to the initial state. Is it fine? Is it clear?
Yes, sir.
Huh. So now the question says that what is the mod of this counter, right? So as you can see, there are only 3 states, 1 2 3. So the ideal modular should be 3, right? Now the problem says there is no option as mod 3 counter, and I'll tell you why. So it says this NAND gate has a propagation delay of 2 nanoseconds. So what will happen due to this 2 nanoseconds? Since the time period of this clock was 1 nanosecond, there will be 2 more clock pulses that will make 2 more state work. So this will not be the next state. What will happen? It will become as 0 1 1 and 1 0 0, and then it will become 0 0 0. So these additional 2 states will come just because of this propagation delay of 2 nanoseconds. It will work for 2 more clock cycles, since this NAND gate will uh, take 2 more nanoseconds to make this work as 0 0 0. Is it clear?
No, sir.
Okay, fine. I'll try to explain again. So you can see what was happening is we are counting, or we were checking when it is 1, we are giving the next clock. So once it got 0, we concluded that the next step or the next stage will be 0 0 0, right? Till here it is clear?
Yes, sir.
Okay, now I'll repeat then. What was the question says that the propagation delay of the NAND gate is 2 nanoseconds. So to make this 0 0 work, it will take 2 nanoseconds for the NAND gate, right? So now the question says that the time period of this counter is nothing but 1 upon frequency, which was given as 1 gigahertz. So the time period or the clock positive edge was coming for every 1 nanoseconds. So you know that for a counter, I have just said that for every positive edge triggered, it will go to the next state. Now since this NAND gate will require 2 nanoseconds to make it 0 0 0, there will be 2 more clock pulses which will work for additionally for this complete circuit. So there will be a 3, there will be a 4, then this get state will get 0 0 0. Is it clear? I did not hear you. Can you repeat?
Clear, sir.
Yeah. So now the thing is happening. Instead of having these three states, it is now having one, two, three, four, 5 states, and then it is going back to the original or the initial state as 0 0 0. So it is nothing but a mod 5 counter, not 3. So these type of question appear in gate like every year. So you need to be attentive enough to solve these problems. Be- because in gate they will give this mod 3 as an option, and everyone will mark that option, and they will not even check this propagation delay. So here there is a trick in this question. I hope it is clear to everyone. Is it clear?
Uh, so there is two. We have added two, the 3 plus 2, right? Then it gets 5. So that we have added two only due to the given time delay is 2 seconds and nanosecond. That's why, or the another reason we have added two.
So yeah, you can see that NAND gate has a time delay of 2 nanoseconds, and the counter was working at 1 nanosecond. So there will
Uh,
be two more clock pulses, right?
yes.
So that is why we have added two more clock pulses.
Okay. Got it.
Yeah. So the correct answer to this problem is option C, mod 5 counter. Yeah, you can take a look. We'll start the next problem in 2 minutes. Okay, so let's proceed to the next problem now. So I'll give you 1 minute. Maybe you can try to solve this. It is quite a easy problem. Any answers? Okay, so I'll write the basic condition for a mod and counter. The basic condition says that 2 to the power m should be greater than equals to n, where m is the number of flip-flops and n is the number of states, or the mod n. So in this question, n is equals to 129. So we need to have a number of m which is greater than equals to. So if I try to put m as 6, it will be 64. If I try to put a 7, it will be 128. So 128 is not greater than equals to 129. So we need to take m as 8 to make it 256, which will follow the condition. Sorry. So the correct answer to this problem is option D. Is it clear? This was quite an easy problem.
So actually, we have to make that option correct. That is the greater than given counter, right?
Yes,
Like here it is given 129. So till it is coming 128 first, m is equal to 7. We have not considered that. Then after when we
yes,
have taken m is equal to 8, then we have considered it, right?
yes, yes, exactly.
Oh, okay, okay, thanks.
Yeah. So if it is clear, so you can try to solve this problem now. I'll give you a minute.
Sir, 9.
Okay, so we'll check again for the condition 2 to the power m should be greater than equals to n. So n is 479. So we just check for m equals to 8. It was nothing but, sorry, 256, right? Okay, 256. It is not greater than equals to, so when we check for 9, it is 512. So yeah, the correct answer is 9 only. Is it clear?
Yes,
Yes,
sir.
sir, clear.
Okay. So now we'll go to the next problem. Maybe you can try to solve this. It is quite a good problem. I can give you 5 minutes for this. Then I'll solve the problem. This is a asynchronous circuit, as you can see. Maybe you can try to solve this, then I'll solve this problem. You can take 3 4 minutes. Okay. So if there is no answer, let me try to solve this. Yeah. So now the question says that output y, this is the output y, it will be 1 when the counter is at the state of 2, 3, 4, 5. So I can write all the conditions. So I'm considering this is MSB and this is LSB. So this will be nothing but C, B, A. So there can be 8 possibilities. Let me write them. It is 0, 1, 0, 1, 0, 1. Okay. And it says the output y is 1 when it is 2, 3, 4, 5. So if I write in the decimal, it is 0, 1, 2, 3, 4, 5, 6, 7. So output is 1 when it is 1, 1, 1, 1, and the rest it is 0. Is it fine till here?
Yes, sir.
So we are taking same for two time, right? We are taking
Sorry?
0 0 0 0 0. We are taking two times for same for the digit like mm, we have taken so 0 0 then after 0 0 then after 0 1 then after 0 1. So we have to take we do have to take two times same.
Where
Do
it is
we need
same
to
in two
take
times? Where it is same?
uh,
I
mhm, in the table only, sir, table, truth table only.
here.
From there only.
So it is 0, 0, 0, and it is 0, 0, 1. Where is it same?
How okay, so we are taking whole thrice together. So then it will not same. Okay. So I was
Yeah.
taking first two day only.
No,
Okay.
no, no. So
Yes.
see, there are three flip flops. So there are possible eight states. So it will start from 0, 0, 0, 0, 0, 1 until 1, 1, 1. So I've written them here only. Those. Is it fine?
Okay. Hmm.
And then it says that for 2, 3, 4, 5, the output is 1. Right?
Yes, sir.
Yeah. So now you can see this is
How we are
nothing.
getting the output?
Sorry.
How we are getting the Y output?
Yeah. So the question says y equals to 1 when the state is 2, 3, 4, 5. So here you can see it is 2, it is 3, it is 4, it is 5. The decimal values. So I've just written 1 there and rest states are 0.
In question it is given, right?
Yeah, it is given here.
Okay. So
Now the
got it.
question says
Yes.
that what will be the output of y such that uh, we will achieve the same. So we'll just make a k map. If we make a k map here, so it will be nothing but c bar c. This will be b bar a bar, b bar a, b a, and b a bar. I'll just write whatever the condition given in the question. It is 0, 0, 1, 1, 1, 1, 0, 0. We can make two pair out of it. So y will be nothing but this will be c and this will be b bar and this will be c bar and this will be b. So y will be nothing but b XOR c. Is it clear? Everyone, is it clear?
Sir, but in the question, output A are also giving the input to the logic gate, sir.
Yeah. Okay, so you are saying that a is also giving some input, right?
Yes, sir.
Yeah, so since the question is like that, that the final expression that we are achieving is only in terms of B and C. So if we just make a, what we'll do, we'll not attach this line, and what we'll do, we'll just attach these two with a NOR gate, sorry, XOR gate, and here we'll write a Y. It will work the same. You can disconnect this. Is it fine?
Yes, sir, but in that question, they also consider A as the input to the logic gate,
Yeah.
right, sir?
Yes, I get it, but since we
At
are
that
getting,
time, at that time, answer C is wrong, right, sir?
see, what I'm saying is we are getting a Y in terms of B and C only. The output, that final output that we are getting, is not dependent upon this A. So we can consider this as null. We'll not connect this. in the final logic gate that we'll be having. We'll be having a two input logic gate, and we'll just connect B and C together with the XOR gate, and then we'll achieve the same circuit. You can check in simulation also.
Yes, sir, I understood what you said, but
Hmm.
in that question, they mentioned A as the input to the logic gate. So XR gate is the wrong answer, right, sir?
No, XOR gate will be the right answer. Why are you saying it will be the wrong answer?
If we consider A also input, that is wrong, right, sir?
No. Okay, so let me clear this. Okay, so maybe you're getting confused by this. So if I write Y is A XOR B XOR C, then you can say that XOR gate will be the right answer.
At that time,
No, if I write this expression, then you are convinced that XOR gate will be the right answer.
no, sir,
Why?
because the output 001 also, why get the one?
Yeah, exactly. Okay, yeah.
Sir, when I do this question, I thought all options are wrong, sir.
No, the thing is, you are getting expression in terms of B and C only, and we require a XOR gate for that particular operation. So that is why here XOR gate is the correct option. We are not saying that we should connect all these three inputs. It is just a black box. You can see it is a box, and we need to calculate Y in some terms of A, B, C, whatever we are getting. So now the thing here is we are getting this Y in terms of B and C only. So we can ignore this A node. In the final circuit, will not make this line. It is something like this. So what I will do is I'll disconnect this, and what I'll do is I'll take the B out and the C out and just add a XOR gate, and then we'll get a Y. You are convinced that this circuit will work if I make it something like this, right?
Yes, sir.
So we require a XOR gate to make this operation or this circuit work, right? I am convinced that you are saying that this there is no relation with the A, but we can neglect this node. It is just a black box. It is asking us to solve in any terms of either A, B, or C. If either B or C or A or C, whatever it will work. We just need to check the expression that which gate it will require ultimately.
Okay, sir. Thank you,
Yeah.
sir.
So yeah, similarly you can check for maybe if I can change this 2 3 4 5 to maybe you can solve this. All of you can solve this. Instead of this 2 3 4 5, you can take, wait, yeah, instead of this 2 3 4 5, you can take maybe let me give you, this will be 0, this will be 1, 2, 3, 7. So yeah, let me tell what is the answer. Instead of this 2 3 4 5, the question says it is 1 2 3 5 6 7. So let me know what is the answer for y and which gate it will require. I can give you 2 minutes. It is 1 2 3 5 6 7.
So here to make a Carnot graph, we are taking the final output only, or we will take a whole truth table, just like 2 3 4 4 5 we are taking, right, as output one. So we
So
will consider that one.
we'll take one for this corresponding given digit. So for 1 2 3 5 6 7, you will take one, and rest of them you can take zero, and then you can make a K map and tell me the relation and the gate that is required.
So here we have made K map
Yeah,
by
yeah, in this
taking.
K map only.
Actually, I have made for that. There is eight na, so we will make K map with eight digit, with the eight
Yes, yes.
digits.
Yes, exactly, 8.
OR gate of A and B, sir.
Sorry, what you are getting?
A OR gate of B, sir.
Okay. Let okay, let me check if it is correct. Yeah, it is the correct answer. It will come something like this only. So what I have done is now I've taken 1 for 1, 2, 3, 5, 6, 7. So I'm writing it for the corresponding bits. It is 1, 2, 3, 5, 6, 7. So I'm filling it in the K map. Let me make some different one. Maybe I can make it here. So it will be 0, 1, 1, 1, and then 0, 1, 1, 1. So what I can do, I can make two quads. This will be nothing but B bar A bar, B bar A, B A, and then B A bar. For the first quad, we'll get A, and the second quad will get B. So we'll get Y as A plus B. So the correct answer to this question will be then OR gate. Then it is A plus B. So I hope the doubt is clear for the previous problem now. Since we are getting something in terms of B and C, so we are writing the answer as XOR gate. Here we are getting something in terms of A and B. Still we are writing the answer as OR gate. Is it clear now?
Yes, sir.
Okay, fine. Okay, maybe we can proceed to the next problem in 2 minutes. Okay, so let's proceed to the next problem now. Maybe you can try this if it is possible. I can give you 2 minutes. So it says that what is the mod value of the below counter. So if it is not clear, this is nothing but A0, A1, A2, and this is A3. And then this is, let's say this is 0th flip flop 1, 2, 3. And we have certain relation, and this is, let's say this is C. Okay, let me do it by myself only, otherwise it will take time. So you can see in the first flip flop, which is A0, this J0 and K0 are directly connected to this C. So I can write J0 equals to K0 equals to C. Is it fine with everyone?
Yes, sir.
Then I'll write similarly for J1 and K1. You can see J1 and K1 are additionally connected to this A naught and then C. So I can write it as C and A naught. For J2 and K2, I can write it as C, then A naught, and then A1. And for similarly for J3 and K3, I can write it as C, A naught, A1, and A2. Is it fine?
Yes, sir.
Okay, so we'll start similarly as we have done in the last problem. So we'll start with what it is. It is A3, A2, A1, A0. Sorry. So we'll start with 0, 0, 0, 0. And yeah, so for the first clock, what will happen? This is count enable, so this will be 1. So for the first clock, what will happen? This you can see it will always be 1. I can write it here also. So for the first A naught, it what will happen? It will always remain 1 and 1. So it will always toggle, right? So we can write this something like this. Sorry, sorry. This A0 is clear to everyone. Any problem in this?
Clear, sir.
Just we
Okay,
have
so
taken
now
0, 1, 0.
yeah, so now I'm writing for J1 and K1. So we have just written the expression for J1 and K1, which was nothing but C into A naught. So we know that in the previous state A naught was 0. So J1 equals to K1 equals to 0. So whatever the previous state will write the same state, right? Any problem in this?
No, sir.
So similarly, these two will also get 0 since A naught is 0. So I can write the expression here also C A naught A1 and then J3 in K3 was nothing but C A naught A1 and A2. So is it fine for this clock? Like this line is clear.
Yes, sir.
So now I'll write for the next clock. So we know that A naught was 1. So this J1 and K1 will become 1. So this state will toggle now, right? And since A1 was 0, so these will remain the same. Is this step clear? Any doubts here?
Clear, sir.
Okay, so similarly I'll write for here. So A naught is 0. So whatever the previous state J1 will remain the same and A2 was nothing but it will also remain the same. Yeah. So I'll write for all the states whatever I'm getting. So here it will be 1, so it will change. Here it will be 1, so it will also change. So I'll write it quite quickly, whatever I'm getting. One, 1100. Then I'm writing here. I will get 1101, 1110, and then 1111. And this will be the 15 digit. Maybe you can check if you have any doubt. I can explain each and every step. Did you get the analogy that how is it coming?
Yes, sir.
Okay. Everyone else also got this.
So we are taking the A1 by past A naught as
Yes.
their input
So
step. Yeah.
yeah. So maybe I'll try to solve maybe some. Let's take this as okay. Wait. Yeah. Let's take this step, and let's check for this. So we know that for the previous step, A naught was 0, right? So
Yes.
J1 and K. So my bad. Wait. Yeah. So J1 and K1 will be 0 since A naught is 0. So whatever the previous state was, we will write the same A1. Is it clear for this A1?
Yes. So in starting, we were when we are making the formula J1 is equal to K1 is equal to 0. So from circuit only we have made this formula, right? Or is it the
Yes.
fundamental formula?
Yes. No,
No, no,
we
no.
have made
Means
it
I
from the
mean
circuit. So you can see here it
from
is A
circuit
naught
only.
and here it
Uh,
is C. So J1 and K1 both are connected to this C into A naught. and this C
Okay.
into A naught is now connected to this A1. So for J2 and K2, it will be C naught A1, A naught A1, and correspondingly for J3 K3, it will be again a AND of C naught A1, A2 and A naught,
Okay, and it is getting multiplied due to the uh,
AND gate.
or or and get, yes, and get, okay, okay.
Yeah,
And get, got it.
fine. Maybe you can check. So we are getting all the 15 states. So this is nothing but a mod 15 counter. So the correct answer to this problem is okay, 16 we are getting. Yeah, we are also getting 0000, and this is 15. So it is nothing but a mod 16 counter.
So till when we have to continue the our counting?
Since we get this 0000 back, so after this 1111, we'll get a 0000.
Okay.
Yeah, so it is a mod 16 counter. So correct answer is option D. You can maybe you can check for this. We can start the next problem in 2 minutes. If you have any doubt, you can ask. Okay, I see in the chat box some of you have written the answer as option C, which is 8. Is it clear now? Because it is 16, not 8. Uh, you have written Anuj and Sudhir, you have written the answer as C. Is it clear now?
No, sir. Actually, my answer was before 9 when
Okay,
there was the.
okay, so I can do the calculation for 9 directly. So you are saying that you stopped it here. So we can check for the same. So you can see it will toggle, and in the next state J1 equals to K1 equals to 0. Since in the previous state A naught was 0, so it will remain the same. Then what will happen? This J2 equals to K2 is again 0, so it will remain the same. And then this J3 and K3 both will be 0, so it will also remain the same. So we are getting from 8 to 9. You are saying you stopped here and then you got all the data as 0, right? Then only you can write the answer as uh, what you have written 9. Sudhir also, you have also written is at 8. Is it clear? I can repeat it if it is not clear. Just let me know.
So actually, we have taken the formula for J1, J2, J3. Na? So then we have find out the value of A1 from past A naught. But how do we go
Yes.
for A2 and A3?
So
And
same is for you can take the past value of everything A2, A3, A2, A1 and A0. You can take from the past and just apply the formula in the next state. So here you can see this A0 will always toggle. So I have just written it as 1. For this A1, we will check the J1 and K1. So J1 and K1 was nothing but C into A0. So A0 was 0 in the previous state. So this J1 and K1 will become 0. Once it
yes,
becomes 0, so you know that for J flip flop, the next state will be same when they both are 0. So I've just written the same here. Is it clear? You know this, right? When j and k both are 0, qn plus 1 will be qn, and when j and k both are 1, this qn plus 1 will be qn bar. It will toggle.
Okay.
So here also it will be 0. J2 and K2 will be 0 since A0 is 0. Since it is 0, we'll write the same bit, Qn. And same with the case with this.
Okay. So this the formula is Kn plus 1 is equal to Qn. This formula is fundamental formula
This is,
Qn plus 1 is equal to
yeah, yeah, this is fundamental. This is from the characteristic table of J and K flip flop.
okay, sir. Got it.
Yeah. Okay, so let's proceed to the next problem now. Okay. The question says that a clock has a frequency of 15 megahertz, which is applied to a cascaded counter of modulus 3, then mod 4, and then mod 5. So the question asks is what is the lowest output frequency and the overall modulus. So the overall modulus is always the multiplication of all the cascaded counters, which is nothing but m1 into m2 into m3 and so on. So we have three modulus cascaded here, which are 3, 4, and 5. So it will give us a overall modulus of 60. And the minimum frequency, which is asked in the question, it will be nothing but the frequency of clock divided by the overall mod. So it will be nothing but 15 megahertz divided by 60. So it will come kilohertz. So it will be 15 into 10 to the 6 by 60. Will be,
250 kilohertz, sir.
yeah, 250 kilohertz. So the correct answer is option B. Is it clear?
Clear, sir.
Yeah. So maybe you can try this question now. It is a similar question. Just let me know the answer. Then I'll solve it. Everyone try to solve it and write in the chat box. Okay, let me solve in 1 minute. So yeah, uh, the question says it has a given frequency of 12 megahertz, and the overall modulus will be, since it is a 4 and then 5 and then 6, so it will be 120, and the lowest frequency will be 12 megahertz divided by 120, which is 100 kilohertz, which is option D. So yeah, all of you are correct. Uh, so we'll start the next question in 1 minute.
s-
Okay, so let's start with the next problem. So it says the three cascaded decade counter. So you need to be aware that sorry, give me a moment. Yeah. So you need to be aware that decade counter means nothing but mod 10 counter. So we have just learned that a cascaded counter for the overall modulus will just multiply it. So
30.
that will be 10 into 10 into 10. That will be 1000, which is option D. Is it clear?
So how much time they will save?
Yes.
If it will save two times, so we will take 100 only, right? Two cast for two
Yes.
casket.
Yes, yes. Then we'll take 100. So it is something like mod 10, then cascaded with mod 10, then cascaded with mod 10.
Hmm. Okay.
So we'll take, yeah. Is it clear? So
Yes.
let's try to proceed to the next problem. Okay. So it says that consider the following sequential circuit with X as an input and a positive SD flip flop, and then determine the self loop state from the state transition diagram. So you must have written state diagrams. We will use the concept of that in this question. So first of all, I'll write the expression, and I hope you are aware that how to solve the state diagrams. So we'll make a table. So first of all, D naught is nothing but X from the circuit. Q naught will be D naught, which is X. Then D1 is nothing but Q naught. I'm just writing it from the circuit. D1 is nothing but Q naught, and Q1, which is a final output, it is nothing but D1, which is Q naught. Is it fine?
Yes, sir.
Yeah. So we'll write the state table, which in which what we'll write? We'll write the inputs. We'll write the input of flip flops. We'll write the next state, and then we'll write the final output. So this is a table that we make generally for state diagrams. So input we can have three cases, since we have, sorry, not three, eight cases. So let me write all the possible cases first. Then we'll write what is the D1 and D0, which are nothing but, okay, let me try to write. D1 is Q naught, sorry, and then D0 is X. Yeah. Then we'll write the next state, which was nothing but Q1 and Q0. Uh, and then we'll write the final output Y. Is it clear till here? Hmm. So we'll just write the Q0 column here, which is 0, 0, 1, 1, 1, 1, and we'll write the D naught here, which is X. So 0, 1, 0, 1, 0, 1, 0, 1. And we know the next state Q1 will be nothing but Q naught. So we'll write Q naught here, and Q naught will be nothing but X. We'll just repeat this again: 0, 0, 0, 1, 1, 0, 1, 1, 0, 0, 1. And the final output Y is, we have just calculated, is nothing but Q naught. So I'll write it again: 0, 1, 0, 1. Is it fine, this table? Any doubts in this table?
It's fine, but why you are taking output as Q naught only? Y is equal to Q naught.
Yeah, so here you can see Y is connected to Q1, right? And for a D flip flop, we know D1 is nothing but Q1. Okay, wait. And we know that D1 is nothing but Q naught only, right? So Y will be nothing but the previous state will write. So Y will be nothing but Q naught. Is it
Okay.
clear? So we know in D flip flop Qn plus 1 is Qn
So can
only.
you please repeat it?
Yeah, sure, I can repeat it. So you can see in this D flip flop, we have a Q naught connected as an input to D1. So we virtually have Q naught here. So in D flip flop we know Qn plus 1 is nothing but Qn only. So this Q1 will be nothing but Q0 only, and this Q1 is nothing but Y. So the final output will be Q naught. Is this clear?
Yes, sir.
So I'll have written all the possible inputs which are Q1, Q naught, Q and X, and corresponding D1 was Q naught, which I have just written, and D naught was nothing but X. So you can see D naught was nothing but X. So I've written the possible values, and in the next state, which were Q naught and Q1 and Q naught. So Q1 was I've just written was nothing but Q naught. So I've written the Q naught column again here, right? I've not written the Q naught column. Yeah, I've written the Q naught column here, and then Q naught was nothing but X. You can see Q naught was nothing but X, so I've written the X column here. And ultimately the final output is nothing but Q naught only. So now is it clear?
Yes, sir.
Yeah, so now we'll make the state diagram. So be attentive. I'll make it slowly. So in state diagram, we write the state in the circles, and we write the input and output in the lines. So it will look something like this. We'll check how it will look. So I can make it here maybe in this page. So I can make it something like this. So first we are taking, oh sorry. So the first state is 0 0, and the next state is also 0 0, and the input is 0 and the output is 0. So we are getting from 0 0 back to 0 0 when the input is 0 and the output is 0. Is this step clear?
Sir.
Then in the next case we are getting 0 0 to 0 1. The input is 1 and the output is 1. So this is 0 1, this is 1 0, this is 1 1. So we are getting from 0 0 to 1 1. The input is 1 and the output is 1. Is this step clear?
Yes, sir.
Then in the next step we are getting from 0 1 to 1 0, which is 0 0. So 0 1 to 1 0, which is this, and this is 0 0. And for the next step we are getting from 0 1 to 1 1, and the input is 1 1 by 1. Is this fourth step clear? Everyone?
Yes, sir.
Okay, so now we are getting from 1 0 to 0 0, and it is 0 0. So 1 0 to 0 0, and it is 0 0. Again, then from 1 0 to 0 1. Oh, sorry. 1 0 to 0 1. 1 0 to 0 1. What is happening? From 1 0 to 0 1, and we have 1 1. Now we are getting from 1 1 to 1 0, 1 1 to 1 0, and it is nothing but 0 0. And the last we are getting from 1 1 to 1 1, and we have 1 1. So the question says that the number of self loops. So self loop is nothing but this one, because it is going in the same state, and this one. So we have only two self loops in the whole state diagram. Is it clear?
Yes. Nice question.
Answer to this problem is 2, which is option C. Any doubts? You can check the table again. Any doubts in this?
No, sir. Okay.
Okay. So let's proceed to the next problem now. Okay. So should I erase this or should I keep it here? Let me keep it here. So wait. Let me try to write here only. Now the question says that a certain JK flip flop has a propagation delay of 40 nanoseconds. The largest modulus of ripple counter, it is asking for the largest sorry, that can be constructed from such flip flop which can operate at 8 megahertz. So it is a general question. So the frequency is nothing but, we know the formula, it is nothing but 1 upon n tau pd. So it is asking for the value of n only. So n will be nothing but 1 upon f into tau pd. F is given as what is f? 8 megahertz, which is 8 into 10 to the power 6, and it is 40 nanoseconds into the minus 9. So it will be 1 upon 32, and this will be 10 to the power minus 3, and then minus 2. So it will be 2. So n will be nothing but 100 by 32, which is nothing but 3 point something, 3 point, maybe 3.15. I guess this will be 9. So now it says the largest modulus of the ripple counter. Yeah, so the largest counter. Wait, let me try to. Okay, yeah. So the largest counter will be 3, and if the question have asked the number of flip flops, so it will be nothing but 2 to the power this m. Sorry. So since the largest counter is this, so we know that it is nothing but greater than equal to 2 to the power m, right? So the number of flip flops used are 2 to the power 3 point something like this, so it will be 8 only. Is it clear?
Yes, sir.
Okay. Okay, I have something in the chat box. Yeah, what is your question, Poonam? Any doubts? You are not audible if you are saying something. Uh,
So in this question, we are going to find out the ripple counter, right? Again, largest
yes,
ripple counter.
yes.
So, so for that, the same formula is we going to apply f is equal to 1 upon
Yes,
t.
this formula will be applicable, yeah, everywhere, yeah, this.
Okay. So what is the 10 power 6 and 10 power 9?
This is megahertz and this is nanoseconds.
Okay.
This is 40 into 10 to the power 9 seconds, and the frequency is 8 into 10 to the power 6 hertz.
Yeah, got it.
Okay, so let's proceed. Poonam, do you have a question? Maybe you can write in the chat box, you are not audible. So, yeah. The next question says, in the given figure, various states. So, question बताएं. So I have already told that this is week 9 session, so we'll cover the problems related to assignment 9 only. In the next week, we'll be covering the assignment 10 problems. Okay, so now we'll start the next problem. It said that in the given figure, various states taken by the counter. So here the MSB is C and the LSB is A. So this is the LSB, this is the MSB. Yeah. So it says that various states. So can you tell me whether it is a synchronous or a asynchronous circuit? Anyone?
Synchronous circuit.
Synchronous, sir.
Yeah, synchronous. So we'll just write the equations of, let's suppose this is maybe 0, 1, 2. So we can write the equation. So we can see J naught equals to K naught equals to 1. It is always connected to high. Then J1 equals to K1 equals to, you can see it is nothing but A. I'm just writing these equations from the circuit. So J2 and K2 is nothing but it is A ANDed with B bar. Everyone agrees? Any doubt in this?
So how we know there is continuous circuit? So that's why we are getting a synchronous.
Synchronous, since it is only using a single clock. and all the flip flops are working at the same time.
At the same time, how?
So once we apply the clock, all the flip flops will work because they are connected to a single clock. They are not dependent upon the output or input of the previous clock. There is no connection between this, as you can see, right? For asynchronous circuit, we have a input output dependence. Is it clear?
So, but circuit is connected for upper side also. There's this
Yeah,
how
so
it is.
that is what I'm saying, that we have a single, we have a clock which is connected to all the flip flops, the same clock. So once we'll give a positive edge, so all the flip flops will work. It is not like this will work, then this will work, then this will work. It will not happen. Directly, if I apply a single clock, all the flip flops will work correspondingly. Is it clear now?
Yes, okay.
Okay, so I hope these expressions are clear. So we'll again start with CBA. We'll start with 000 since all the options are starting from 000. Now we'll try to write. So again, this J naught and K naught both are 1. So you can see it will always toggle this A. So let me write 0 1 0 1 0. And then this B is it is dependent upon J1 and K1, right? Yeah. So J1 and K1 are A. So as you can see, A is 0 in the previous state, so B will remain the same. And then J2 and K2 is A B bar. So it will be also 0. It will remain the same, right? Is this step clear? Let me write also here J1 and K1 are 0 and J2 and K2 also are 0. From the previous state, we have just used these expressions. Is it clear?
Yes, sir.
Yeah. So here J1 and K1 will be 1 and J2 and K2 will be B bar. Will also be 1, I guess. Yeah. So both of them will toggle. It will be 1, it will be 1. Is it fine?
Yes.
Then in the previous state here J1 and K1 will be uh, A 0 and J2 and K2 will also be 0. So it will remain the same. I hope it is clear what am I am writing. Will be 1 and this will be 0. So this will remain the same and this will toggle. Then in this state J1 and K1 will be 0. This will remain the same and J2 and K2 will also be 0. This will remain the same. Again J1 and K1 are 1, so it will toggle, and J2 and K2 are 1. It will also toggle. Here J1 and K1 are 0 and J2 and K2 are 0. So it will be 0 1. Okay, so let me write it more. J1 and K1 are 0, sorry 1, and then J2 and K2 are A B bar, so 0. So it will remain same, it will toggle. Okay, so we have reached the state back. Is this clear? The whole diagram. Any doubts? Anyone having any doubts in this? You can ask. Am I audible?
Yes.
Yeah, so is it clear?
Clear, sir.
Okay, so I'll write the states whatever I'm getting. I'm getting from 000 to 001, then I'm getting to 110, then I'm getting to 111, then I'm getting, sorry, then I'm getting to 110, right? Sorry, then I'm getting to 100, then I'm getting to 101, then I'm getting to 010, then 011, and then again 000. So we'll check the options. So we have 0 0 0, then 0 1 1. We have these two, then 1 1
C
0.
option.
So 1 1 1 1 0. Yeah, option C is the correct answer. Is it clear?
So when we are making truth table, at that time, we have we are just taking reference from A, right? If there
Yeah,
is
from
a zero, so if there is a zero, so J1 and K1 will be zero, right? If there is one,
yes,
if the A is one, so J1 and K1 will be one, right?
yes,
Then
yes.
after J2, then after J2 and K2 will depend on
A B bar.
then J2 and A B bar, right. Nice,
So
nice,
if they are
got it.
0, so the state will remain same, and if they are 1, the state will toggle. Fine.
Yes, sir. Fine.
Okay. So let's proceed to the next problem. For the circuit shown, maybe you can try this problem now. It is similar to what we have done above. I can give you 2 minutes. You can try. This is a
We will
synchronous.
get the recording.
Sorry.
So after the session, we will get the recording, right? This session.
Yeah, yeah. You will get this on YouTube.
Oh, YouTube channel, NPTEL YouTube.
No, we TAs have a YouTube channel, so we upload every lecture's tutorial on the YouTube. Maybe you can search. I can
So
write
could you
my.
please post? Uh,
You can type this on YouTube. Maybe will get it. For every week, we upload the lecture, whatever tutorial we have. So yeah, any answer for this problem, or I'll solve it. Any answer? Subscribe. Okay. Yeah. Thank you. Oh, shall I solve it or you are solving? Okay. So let me solve it then. I don't get any response. So Q1 is 0. It will start from 0 0, and this D naught is nothing but Q1 XORed with Q naught. It will be Q1 Q naught. Right? Is it clear? So we'll write the same Q naught here, and then this Q naught will be 1. Then we'll write the same here, and then this will be 0. We'll write the same here, and this will be 0. So yeah, we have got from 0 0 to 0 1 to 1 0 to 0 0, which is the option B. Is it not solvable? Because I don't see any answers from your side. It was quite easy. Any doubts in this?
Okay.
Sorry?
Okay, sir. It is clear.
Yeah. So you can try to solve this now. Maybe you can do it fast because we don't have much time left. It is a similar problem, just it has three flip flops now.
so once go the last question, please.
Sure, okay. So we have a Q1 Q naught which is initially 0 0 I've taken, and you can see this Q naught is dependent upon Q1, which is getting NOD with Q naught. So we are getting this expression, so we will use the same expression. Uh, wait, we'll use the same expression to solve Q naught from the previous state. So this Q naught is just getting shifted to D1. So Q1 is Q naught. So we are getting this expression. So Q1 will be Q naught. So I'm writing whatever Q naught in the this side, and I'm using this expression from the previous state to solve this, and similarly for all the states.
So D naught is equal to Q1 plus Q naught bar. That's the we are getting from the circuit.
Yeah, D naught will be Q1 and Q naught getting NOD. So I've just written as Q1 bar, Q naught bar. And D1 will be nothing but Q naught only. So Q1 will be Q naught. So I've just written Q1 will be Q naught in the next state, and in the next state Q naught will be Q1 bar, Q naught bar. Is it clear?
Yes, okay.
So yeah, just do this question then. We don't have much time, so try to do it fast. Maybe I can also do it with all of you. So Q2, Q1, and Q0. Okay, so let's start from 0, 0, 0. We know that what is happening here is D1, Q1 will be Q naught, Q1 will be Q naught, and Q2 will be this, and the last Q naught will be Q2 bar, Q1 bar. Is it clear, everyone? This will be Q naught, this will be Q1. This is the expression. I hope it is clear. So I'm solving it. So it will be 0, 0, and this will be 1. This will be 0, 1, and this will be 0. This will be 1, 0, and this will be 0. This will be 0, 0, and this will be 1. Okay, so we are getting it back, I guess. Okay, what did I do? Sorry, this will be 0. I guess I've done something 0, 0, and then 1, 0, 1, and then. Okay, yeah, so this will also be 1. Sorry. Then this is all wrong. This will be 1, 1, and then 0. This will be 1, 0, and then 0. This will be 0, 0, and then 0. Yeah. All of you are getting the same answer? Anyone? So we are getting 1, 2, 3, 4, 5 states. So it will be a mod 5 counter, which is nothing but a divide by 5 counter. Any doubts in this?
No, sir.
Okay. Okay, so I'll proceed to the next problem now. Okay, so it says the maximum clock frequency in megahertz for a 4-stage ripple counter. 4 states, so n is 4, and a propagation delay is 20 nanoseconds. It is saying maximum clock frequency. So we have just read the formula. F is nothing but 1 upon tau PD. You can just solve it. It is 4 into 20 nanoseconds. So it will be 80, it will be 100,000 to 10 to the 6. Since it is asking in megahertz, I guess. Yeah, in megahertz. So it will be 8. Okay, I've done something wrong. I got 1 ja and then 12.5 megahertz, right? The correct answer is 12.5. It was quite simple. I hope it is clear, right? Any doubts?
No, sir. Clear, sir.
Uh, Okay, so you can take this problem as a homework problem for the next week. It is again a same question. There is some dependence, so it is a synchronous circuit as you can see, right? So there is some relation given with the previous state. So you can already, this is a OR gate, this is a OR gate, and this is a AND gate. So you can just write the expression and make the tables, and you can tell me the value of n in the next class. Is it fine with everyone? This is a homework problem for the next week. Fine. So maybe we can end the session now for this week since we are out of time, I guess. So it was great interacting with you all. So I hope it is clear and it has made some of your concept more clear from the previous state.
Sir,
So we'll,
once please. Hello.
sorry,
Please once, go to last question.
this
Before
one,
last. If before last, yes, before last, yes.
this one.
Sir, here when we are taking the 000, can first we are making to table by general for general, right? 0000001. Then after zero
No,
one
no, no,
zero.
no, no. No, no, no. We have just written this 000. Then we are writing
Mhm.
everything with respect to this relation. This both are getting shifted. I have made the arrow. So this 00 is getting shifted here. Since Q1 will be Q0 and Q2 will be Q1 in the next state. So you can see Q2 will be Q1 and Q1 will be Q0. And this Q0 will be some relation. So I've written the relation here Q2 bar and Q1 bar.
That's the thing
So
only. Yeah?
yeah, yeah. So I
And
hope, yeah, yeah, yeah.
here it is divided by 5 counter. So two,
Yes.
three, four, five,
Since,
6. But we are
no,
not counting for whole.
we are having
Okay, okay,
five
got
states
it.
1, 2, 3, 4, 5. This 000 is
Ah,
repeated.
okay.
Yeah.
No, sir. Completed. Yes, got
Oh,
it.
okay. So
Thank you,
yeah,
sir.
Thank you, sir.
yeah, no problem.
Yeah.
So we'll start the, sorry, we'll have the next session in the next week on Monday, same time. So till then, maybe study more and all the best for exams. Thank you, everyone. You can leave.
Bye, sir.
Yeah.